So on your screen there's two formulas. I suggest you pause the video to write these down, and then I'm going to go through a couple of examples on how to use these. So the first example here is the integral of 5x minus 1 to the power of 9, and the formula we'll be using here is the integral of this Alright, so at this point we can look and try to substitute things in. So obviously my a is going to be 5, my b is going to be -1, and my n is going to be 9. So we can go and substitute these in. Now really we don't need to focus on this part because that's just saying what we're looking for, what we're using. So what we're really focusing on is the right hand side of the equal sign. So we end up with 5x take away 1 to the power of 9 plus 1, and this is all over 5 bracket 9 plus 1, and then remember your plus c, that constant at the back. So now we can start to simplify this down. So we end up with 5x minus 1 to the power of 10, not 16, 10, and this is going to be over 5 times 10, which is 50, and then we put our plus c at the end. Alright, so that was all there is. You just literally substitute into the formula and get your answer. So now we're going to look at the next one. So here we're going to be using this formula. And we do the same thing. So my a is going to be 3, b is going to be 1, n is going to be -4. So the 2 out the front is just going to be a constant, so we can just add that out the front here, and we get 3x plus 1, -4 plus 1, all over 3, -4 plus 1, plus c. So if we simplify this down, we end up with the 2 remaining, so 2 bracket 3x plus 1, we get -4 plus 1, which was -3, all over 3 times -3, -9 plus c. So now we have a different type of question. This time we have a definite integral. So you do the same thing, and this one's involving the same formula. Except this time we won't need plus c because we've got a definite, so dx. Alright, so now that we got that, this is going to equal a, which was our 2, so -2x plus 3 to the power of, our power was 5, so 5 plus 1, all over -2 bracket 5 plus 1, 2 and 0. So I want to simplify what's inside first before we keep moving on, and we get -2x plus 3 to the power of 6, all over -2 times 6, so -12, and it's to the 2 and the 0. Now remember, with this one, it's going to be our top function first, so our 2. So what we're going to get here is we're going to have -2 times 2 plus 3 to the power of 6 over -12. We're then going to minus our second. So here, and we got -2 times 0 plus 3 to the power of 6 all over -12. Now you can put that in the calculator and you end up with 60 2/3. So here we're going to be using a different formula this time. We're going to be using the other one. So the other formula was now the first thing to test is if I differentiate what's in the brackets up here, do I get what's out the front? Now if I differentiate x to the power 3, I do end up with 3x squared, so that's good. We don't need to do any changing. So what we get here is 1 over our power, which is 3 plus 1. We get our function, which was x cubed plus 1, and then 3 plus 1 up here. Now remember, you always have to have your c for an indefinite integral. So we get 1 over 4, x cubed plus 1 to the power of 4 plus c. And if we want, we can just tidy that up a little bit more and go x cubed plus 1 to the power of 4 over 4 plus c. Now here is a more difficult one because what's out the front doesn't match what's inside. So first thing we need to do is differentiate what's in the brackets. So alright, to do that, we start with 2x squared plus 3, and that becomes 4x. So if I say this is just y, for example, we get 4x. So really, the number we need out the front is 4x. We have x. So we need to convert that to 4x by multiplying it by a number. Alright, so that number is going to be 1 over 4. So what I'm going to do here is we go like this, and we go 1 over 4 times 4x, bracket 2x squared plus 3 squared dx. So that x here has been converted to this here. So x is going to equal 1 over 4 times 4x. Because we needed that differentiated, we needed this here out the front somewhere so we can use the formula. So we forcibly had to alter it to make it, and we did that by changing x to 1 over 4 times 4x because they're the same thing. Alright, now that we've got that, we know that 1 over 4 is a constant, so that can come out the front of the brackets. So 1 over 4, we get 4x, 2x squared, plus 3 squared dx. Now this fits in with our formula that we just used, so we can convert this to 1 over n plus 1 fx. Let me just change these brackets to n plus 1. Alright, so knowing that, we get 1 over 4, we get 1 over 2 plus 1 here, 2x squared plus 3 to the power of 2 plus 1. And we don't need our c, but we do need to make sure we add our ranges there. Okay, now that we've got that, we can simplify a little bit. So we get 1 over 4, 1 over 3, 2x squared plus 3. Actually, let's make it even simpler. 2x squared plus 3 to the power of 3 over 3. Now we do the same thing that we did before. We need to keep the 1 out the 4 out the front, and we focus on adding this 2. Replace all our x's with this first. So what we get is 2 times 2 squared plus 3 to the power of 3 over 3. And we're going to subtract the bottom number. So 2 times 0 squared plus 3 over 3. Oh, and that's cubed there. So if you do that, you end up with 1 over 4, and we're going to multiply it by 1,304 over 3, and your answer is 108 2/3. So that was a more difficult one. So remember, with this type of question here, what we needed to do is we needed to alter that front x because it wasn't the differentiation of what was in the brackets. So to do that, we first find what we needed, and we needed a 4x out the front, and then we said, well, how do I get from 4x to x, and you multiply it by 1 over 4. So my x changes to 1 over 4 times 4x, and then we go from there.